Hello again everyone. In today's video we're going to look at this scene that we've been making in desktop mode and testing it with the first person controller, and we're going to play it properly in VR. We'll check that these keys are working and that they can open the door. We'll connect the gun to the VR player's hand, and then we'll add a script so that the gun can be fired by pulling the trigger on the VR controller instead of pressing control. Then also I'd like to add a target for the gun to shoot at, and the target will count the number of hits. So let's first of all set up the project to actually work in VR. So I'll turn off the FPS controller and turn on the Steam VR player. I will go to the project settings and let's go to the player settings and make sure VR is at the top. So we'll switch from none at the top to open VR at the top. So this means that if there's a VR headset connected, we will try to run it in VR first. Okay, let's test it out. So I'm going to hit play. The VR view should go maximized so you can see what I see. Yeah, okay, I'll just move this Steam VR out of the way. Okay. We wake up my controller. So once I wake up the controller, you should see it in the view. There it is. Okay, so I've turned on the controller, you can see that. Let's turn on the other one, and I'll try to pick up one of these keys and use one of these keys. Okay, there's my hands working. I'm going to teleport over to this desk and pick up a key. Okay, I've got the key. I'll teleport over to the door. Let's see if it works. There we go. The door was destroyed, so the scripts are working properly. The keys can destroy the doors. Let's now connect one of these guns to the player's hand. So over here in the hierarchy you can see the Steam VR player. Let's expand this. It has Steam VR objects underneath it, and there it has right hand and left hand. Let's connect the gun to the right hand. So I'm not going to use the bubble gun, I'm going to use the regular gun here, the one that we made that shoots normal bullets. Let's drag this up to the right hand. Now let's set the position to 0, 0. 0, so that it's snapped onto the right hand. Now you can't actually see the right hand in the view until the game is running. When the game is running, Steam VR creates the hand object, so I'm not sure what the alignment will look like until we run the game. So let's run the game and then pause it and then correct the hand. So I'm going to run. Let's bring the right hand over. Okay, there's the gun is over there. So the gun is way off. Let's just put the controller down and pause the game. And now I'll correct the alignment of the gun with the hand. Now remember, the changes that you make at runtime are not saved. So we will need to copy the translate value back to the gun when it's paused. Let's line this up with the hand. Looks like the rotation is off a little. Okay, so I've approximately lined this up. I think it's about there. Now what we can do is copy these component values, stop the game, and then paste the values back in. Right, now I'll run the game again and we'll see if the gun is lined up with the hand this time. Okay, there's my right hand. It's close. The rotation's a little bit off, but it's not bad. So now what I'd like to do is to be able to pull the trigger on the controller and have the gun shoot some bullets. I'll just move the gun a tiny bit to the right. Should be better. Okay, Valve provide a whole lot of pre-written scripts to access all the different controller inputs. Let's go and add a component to the gun, and we'll type Steam. And now let's have a look at all the different Steam scripts. So all these are provided by Valve, ready to use, and this is the one we want. Steam VR behavior Boolean. A Boolean is a value that's either true or false. It can turn on or off. And we can use this to check if the player has pulled the trigger. So let's add this. So it says Boolean action. What action do you want to detect? Let's select from the list. And we can see this one here, grab pinch. Grab pinch is the name they use for pulling the trigger, because normally it's used for picking up objects. So we're going to detect grab pinch. So we'll put that in. Now we have an option for many different callbacks. So when grab pinch happens, we can get a callback whenever it changes. We can get a callback every update, when it's pressed once on this frame, or when it's released. On press is like a get key. It returns true every frame that the trigger is pulled. On press down returns true once on the one frame when the trigger is pulled. So that's a very good one. We'll use that to detect when the trigger has been pulled and fire the gun. So let's now open up the gun script. I'm going to go to Open C# project and have a look at the script that's currently on the gun. So let's go to scripts, gun. Alright, so it's doing input, get key down, and it's using the left control key, and then it's firing a bullet. Let's create a new function to shoot the bullet. Now, I've made this public so that SteamVR can see it in the editor. I'm going to take all the code that we used to have for shooting the bullet and put it in here, and then I'll just put shoot in here. So this will do the exact same thing. When the player presses control, it will shoot, and shoot will jump to this function, and all the previous action will happen. But now what I want to add in is I want SteamVR to also call this shoot function. So we'll save this. Back to Unity. Now we're going to use on press down. So we add an event here. It asks you which object is going to do this command and what command are they going to do. So we want to use the gun object, so we put that in here because that's what our script is on. Now we have to find the function that we want to call. So open up the list, go to the gun, and there's my shoot function. Now this shows up because I made it public. So I click on that. So this says when SteamVR detects the grab pinch action on the frame when it's pressed down, it will find the gun object and it will tell it to call the shoot function. Let's test that. So I'll pick up my controller, pull the trigger. There we go, there's the guns. The bullets are firing. Now I noticed that there's no gravity on them. They're stopping very quickly. We could change the prefab to make the bullets behave a bit more normally. Let's see. Let's check the gravity settings and the project settings. So we'll go to physics, gravity. Let's see, what is the gravity set to? The gravity set very low, so we set it down very low because of the underwater effect we wanted to achieve. So let's change that to minus 9.81. So that's standard Earth gravity. Let's also take a look at our bullet prefab. If we go to prefabs, there's the bullet, and it's probably got a very high drag. Drag 10. Okay, let's bring that down to 5. Okay, another thing I'd like to do is have a sound effect play when the gun shoots. Let's make a sound effect. I'm going to use SFXR. This is a fun little program that does chiptune or retro style sound effects. Every time you click on one of these, it generates a new random sound effect. So let's get a shoot sound that sounds good. Okay, that's going to be my shoot sound. I like that one. So let's export the wave. Actually, first of all, I'll go to Unity and make a folder for audio. So here's my assets folder. Let's go create a folder for audio. Now I can save this WAV file into that. So let's go to my projects, VR example, assets audio. We'll call this gun shoot. Okay, so now that will show up in Unity. Here's the gun shoot effect. Let's add that to the gun. So we go to the gun and add an audio source. So where's audio source? There it is. So audio source wants a clip to play, so we drag the gun shoot in there. Now this checkbox play on awake means it will play when the game starts, so let's turn that off. We don't want that to happen. When we want it to play is when the trigger is pulled and the gun shoots. So let's go to the script and let's play the sound effect in here. I'll zoom in a little so you can see this. There we go. So to access my audio component, you say get component, audio source. And then you want to play the sound, so we say .play. And that will play the shoot sound. This will work on any object that has an audio source component added, and it will play whatever sound effect is in there. So when we shoot, the gun will find its audio source and tell it to play this gun shoot sound. Let's test that. There it goes. The bullets now move faster and they have proper gravity. It's a bit loud. I might turn down the volume on that. Let's go to the gun volume here. Let's put that at 0.4. Alright, now I'm going to add a target that we can shoot at. I'll make a cube game object to be the target. Scale it down appropriately. Let's give it a new color. Oh, I already have a target material, look at that. Okay, I'm using too much red. Let's change this. Let's make the target Steam VR blue. Alright, we'll put this behind the table so that you can shoot at it. Let's add a counter so that it can tell you how many times it's been hit. So I'll go game object 3D text mesh. Let's use a text mesh pro text. So this is 3D text. Now I haven't used text mesh pro before, so it's asking me to import the essentials to make it work. So let's click on that. This is basically installing the asset so that I can use text mesh pro. Alright, we have a new text object. Sample text. Let's make this say let's start it at 5 and it will count down the number of hits, and when it gets to 0 the target will be destroyed. Okay, so we'll make this a little bit smaller. Let's link this to the target cube. So this is going to be the target cube that we're shooting at. Let's link the text to the target cube and set its position to 0, 0, 0. Move it forward a little bit so we can see it, and then scale it down. So every time we shoot the cube, we'll decrement the number by 1, and when it gets to 0, we'll destroy the whole thing. So obviously we will need a script on this cube to track the number of times it's been hit. So let's create a new script. Create a C# script. So we'll call this a shooting target. I already have a target script in this scene. That's from some other objects we had which you could throw a ball at. They're gone now. Okay, so shooting target will go on this target cube. Let's now edit the script, shooting target. Right, what do we want to happen? We want to detect a trigger enter. When the player shoots the ball at the target, we want to know when it has entered it. So we'll use onTriggerEnter. So if I start typing onTrig, you'll see it has detected onTriggerEnter, and I can hit tab and it will fill in the whole function header for me. Let's just do a debug log just to get this thing going. Let's just do debug log target hit. It's a very good idea to quickly test your triggers rather than spending 10 minutes writing code then going to the game and finding it doesn't work. It's better to just quickly check that your triggers are working, because there's a few things you need to set up. For a trigger to work, first of all, it needs to have a collider. So let's go to the target cube and have a look. It has a box collider. Next thing is the collider has to be set to a trigger for onTriggerEnter to get called back. Let's make sure the text does not have a collider, because otherwise it will block the bullets. Okay, it doesn't. That's good. The next thing is the trigger will only activate when a rigid body enters it, but that's okay because our bullet has a rigid body. There it is there. So when the bullet enters the trigger, we should see a debug log down here. Let's test that. Okay, I can shoot the bullets. Now let's aim at the target. Now if you see in the console, it says target has been hit down in the bottom left. Down here. So that means my script is working, my trigger is working. Now I can confidently move on and add some more complex code to this. A sound effect would be good. Let's add a sound effect for when the target is hit. So let's have a hit sound. Maybe a coin. That's a nice one. Okay, so I'm going to play this every time the trigger is hit. So once again, I save the WAV file. Target hit, you call that. Back to Unity. Go to my target cube and add an audio source. Then you drag in the clip in there. So let's go to audio, target hit. And then I'll just lower the volume a little. 6. And we don't want it to play when the game wakes up, so we turn that off. So now it should be able to play this. Now we'll need to add the code to actually make it play the sound. So turn off the debug log. We know that works. Let's play the sound. So I say get component audio source dot play. And that should play the sound effect. And once again, I'm going to jump right back and test it. So before adding in more code for the score, I want to test this straight away. I find it's very good to test regularly so that you catch bugs as early as possible. It's working nicely. Oh, now the bullets are going through the target, which doesn't look very good. Let's destroy the bullets when they hit the target. So we'll go back to here and let's destroy that. Now you see it says collider other. That's a little link to the other thing that hit the target, which in this case will be the bullet. So let's say destroy other game object. Destroys the bullets. Now we would like to change the text. So in order to access the Text Mesh Pro object, I have to add in the library. So I say using TM Pro. Now actually it doesn't have it. So my Visual Studio Code doesn't have the full Text Mesh Pro library built in, so I need to Google this. Now normally you can just use Text Mesh Pro by saying using TM Pro. But my Visual Studio is not set up correctly. It's not recognizing this library, so I'm not going to use it because that would be confusing. I'll switch to a different type of text. So let's go back to the editor. Let's get rid of the Text Mesh Pro, and we'll just use standard Unity text. So you can go to Game Object, UI, Text. And this creates text on a canvas. Now it seems to have put it here, which is interesting. Let's take it out of there. So I'll need a canvas to put this on. So let's go to the target cube. Let's go Game Object, UI, Canvas. We'll make a canvas world space so that it's actually 3D. So canvases get created in screen space and they get created very large. So let's make this much smaller. Let's make this 2, 0, 0, and then make the width and height just 2 by 2. Let's connect the canvas to the target cube. So this canvas is like a container which can hold a text object. Let's now find that text and bring it down to the canvas. There. Set the position to 0, 0. And it seems to be here. It's just really small. Okay, there's my text. It says new text. So let's set this to say 5. I'll make the font size bigger and we'll make it white. Let's have it centered. Let's have a bigger font size. Now, you'll notice when I scale up the font size, it disappears. Once it gets bigger than the container box that it's in, it can't draw it anymore. So you need to make the actual object a bit bigger. So let's make the width 500 and the height 500. And now I can scale up the font size. Okay, now we have a nice clear 5. So this is using Unity's Canvas system, which has many other user interface or UI fields like buttons and images. We'll use this because the code is working properly. So now I can go to my script and say using Unity Engine.ui. Actually, it should be just UI. Now, even UI is not working, and I should definitely be able to use Unity Engine UI. That's the user interface classes. So there seems to be a bug in either Visual Studio Code or in Unity in some way. Googling it shows somebody else has the problem. So I'm going to show you how I fix this, because this kind of thing happens to you all the time. You might follow a tutorial on YouTube, but when you do it, it's slightly different and things don't work. So you need to figure out how to solve these kind of things. So I'm going to show you how I solve it. First of all, I Google the problem. Visual Studio Code, Unity can use UI. And I found somebody on answers.unity.com asking about this very same thing. And so this answer has been highlighted. It says if you're using version 1.14 of the VS Code plugin, try downgrading it. Okay, so let's try and follow that. Let's go to Unity. We go to the Package Manager, Window, Package Manager. Down here it says Visual Studio Code Editor, and there it is. Look, it's on version 1.14. Let's see how we downgrade it. Let's go to see all versions. Now, what does it say? It says downgrade to 1.13. Okay. How do we do that? And if I double click this, there we go. Update to 1.13. Okay, so that's really downgrading it. All right, now we're on version 1.13, so let's close Unity. Let's save the project first. Save scene, save project. Kill that. Now it says we should delete the project, the C# project, and the solution files. Okay. So let's go to projects, for your example. Here's the CS project file. Let's delete all these. Those will get remade when you open up Unity and say open C# project. Okay, open Unity and that fixed it. Okay, let's see if this fixes it. So I'll use the hub to open the right version of Unity. We're going to skip the new editor. Let's move this out of the way. Now, hopefully now, let's restart Visual Studio Code. Hopefully now it will be able to use the UI. So let's go open C# project. Good, now the error message is gone. So this is what should have happened. I should have been able to type unityengine.ui and it finds it in the list and there's no errors. And this will allow me to access the text. So I suspect Text Mesh Pro would have worked too if I'd fixed this setting. And the reason why I've recorded fixing this is because I want you to see that this happens to everybody and you have to struggle through these kind of things. You can't let unexpected errors stop you. In any game engine, they're constantly adding new features and you have to deal with unexpected bugs and crashes. Okay, let's now access this text. So if I make a public text, I'll call this my countdown. Now that text is coming from Unity Engine UI.txt. So that's why I needed to install Unity Engine UI to be able to access the text, and that's why I needed to fix the Visual Studio Code plugin inside Unity. So now we can access a text object. Now we need to keep track of how many times we've been hit. So let's make a private countdown variable. Private int, an integer. And we'll call this the countdown. So this should call my countdown text. Let's call this the counter. And we'll start it at 5 when the game begins. Now, when we've been hit by the bullet, we play the sound, we destroy the game object, we should decrement the counter. We should realize we've been hit once, so we'll say counter minus minus. So it will go down 1, and then we should set the text to read the new value. So we'll say my countdown text dot text, which will change the actual value, is equal to, and we'll put it in counter, which has gone down 1. Okay, now we'll need to convert that to a string so that it can be displayed inside text. So you just put toString on the end of an int, it converts it to a string. Okay, let's give that a test. Back to Unity. The target cube now has a countdown text variable. It wants to know where's my text. So let's go in here to the canvas. There's the text. Let's put it in there. So now I can change the text. Now play the game and shoot the text, and let's see what happens. Okay, I need to wake up my controller again. Once it wakes up, we should see the hand. Now, I don't know if the gun will work. Oh yeah, the gun does work. Okay. Right, we can shoot. The controller is vibrating. I think it's because there's a collider on the gun, and the hand is interacting with that. So let's get rid of the collider on the gun. That's causing the hand to move in a strange way. So, where's my gun? It's a child of the right hand in here. Where's the gun? The gun has got these cube objects underneath it inside graphics. I bet these have got colliders. Yes, so let's turn off the colliders on these. These are messing up the position of the hand, and they're causing the controller to rumble because it thinks it's interacting with a physical object. Okay, that should fix the rumbling in the controller. Alright, that's better. The controller's now nice and quiet. We can shoot. Let's shoot this. It works. Of course, it keeps going down. We need to put in some code to make it destroy when it gets to 0. So let's check the counter value in the script. We'll say if the counter is greater than 0, we will do this, which is decrement the countdown. Otherwise, we'll just destroy the whole thing. Else, we'll destroy this game object. Now, this will also destroy the text object because it's a child of the game object. So when you destroy a game object, which is a parent, the children get destroyed too. Okay, let's test that. That works. Let's shoot the target. And then the whole thing is destroyed. Good. Okay, I hope this was useful to you. A quick reminder, if you want to see specific things done in these videos, you can go onto the class Discord and ask me. In the upcoming classes, I am going to try to give you some feedback on your Assignment 3 project. So if you would like some one-on-one feedback in a Zoom conference call, you can email me or chat to me on Discord. You don't need a webcam. You can share your desktop, and I'll take a look at your project, and then I'll give you feedback. So let me know if you'd like one of those. Okay, thanks for watching.